When we started looking at the data from the STAR test and looking at the data from our 9-week SBA, it was apparent to us that we have some weak areas in area and perimeter. And so we want to try to address those to take care of those weak areas. You have stations set up, 2nd grade all the way through 6th grade, as well as a web station, a foldable station, and then over here is a Door Explorer station. The handouts that I gave you give some details on each one, the SEs that are covered, the materials that you need for each station, and you'll be able to go to each station and work through it. And then in addition, we have some other materials up here for you to take on your way out.
So we're doing guided math workstations, and whenever you're doing guided math workstations, the original teaching has to happen. One way to solidify that teaching and have something for the kids to anchor their learning to is, of course, anchor charts. So we have anchor charts that are going to be placed up some ideas, and maybe we can make some of our own. Also, we have projects that they could complete within the classroom. I have a whole list of projects here. One of them is classroom decorating, where they're going to place wallpaper on a wall and then trim it up. So once again, they're doing perimeter and area, but it's application. Another one for our boys out there who love football, they're going to actually design a stadium, determine how much concrete, how much grass they need, how much fence needs to go around the entire property. So once again, we're doing perimeter and area. And then we have a garden project, so the kids get to actually determine which project they want to do and then go with it. For the lower grades, these are we have a set of shapes. We want them first to order them from least to greatest. And then what they get to do is determine what the area and the perimeter are of them and see how close they were. Pretty fun, pretty simple. This one, they're actually just comparing two shapes. This looks more like what we're going to actually see on the STAR test, but it's hands-on. We're taking two shapes, we're looking at them, we're comparing the area, we're comparing the perimeter, and we're asking ourselves which one's bigger.
At the 2nd grade table, we're going to show teachers how they can use items that are in their classroom or around the school to begin that concept of what a square area looks like, that it's a flat area. We have here models where teachers can show their students and make this again in their classroom so that students can have an understanding of that 2D dimensional shape that's going on with area. We can also extend this activity where students can find items that are in their classroom. They can count the square tiles that are on the floor in the gym. They can count the ceiling tiles that are above their head in the classroom. This will bring that concept up to a higher level for them to understand that. We have hands-on items as well at the back table, where students can count squares, maybe on the cafeteria wall, maybe on a counter at home. Or perhaps they can even lay out napkins in a square area. So this just lays the foundation as they go into 3rd grade and 4th grade of what area looks like in the beginning that's on their grade level. At the 3rd grade table, we start now showing them what the release questions look like on the STAR test. Yet we need to go back and build that concept of what perimeter is. So when the students need to understand that perimeter is a length, it's a 1D dimension. So we have rectangles here, and we have a square, so the students will actually measure them with a non-standard unit, and then they'll move to their standard unit, which can be a ruler or a yardstick, and then they can record the dimensions there, the perimeter of that, on their exit ticket. Another thing they can do is take a perimeter walk around the school. They can take the perimeter of the gym, they can draw that, they can go outside and understand that the fence around the school is a perimeter. They can record that, that gets them up at a higher level. They can create their own problems about perimeter that they might see on the release STAR test.
This is a 4th grade table, and the idea behind this table is for the students to understand that even though the area stays the same, we can change the perimeter. So what they're going to receive is 12 tiles. They're going to lay them out and trace the object, determine the perimeter of the object, and then change the same 12 tiles to create a different perimeter and calculate. We want to see the relationship between the two. Then what we want them to do is do it a 3rd time and see if the area increased, or the perimeter increased or decreased, comparing the two objects. Then the extension of that is to change the area to get a larger perimeter and see if they can get the largest perimeter they can find with different areas. They have an exit ticket from this as well. We also have the 4th grade STAR release questions, and we have extension questions that take it to the application level for this grade level. Okay, this is our 5th and 6th grade table. What we're doing is a lot of teachers have done the students' names before, have the students determine perimeter. But what would be the best way to do this hands-on? A lot of times the students have a hard time seeing their name in blocks. So what we're going to do is they're going to lay out these centimeter cubes to create their name. Then they're going to compare each letter to each other. And then they actually can compare themselves to their friend. We'll then create a bar graph from the names and then apply that to questioning from that. So they can build questions from the bar graphs. Once again, we have 5th and 6th grade STAR questions and extension activities from this. Okay, so what we've talked about here is introducing technology into your workstations. We have several laptops set up here with different websites that are interactive that not only teach the students how to determine perimeter and area, but also take it to that level of having to apply it and do something with it. It's not just a fun game to play. We also have an opportunity for the teachers to search and find any suggestions they have, and then we'll share those out at the end.
Here we've created a real-world example for students to see that area can be even a Christmas present that's wrapped. Then you can see that that's that flat coverage. That area is 2 dimensions, that it has length and width to solve, so that even at Christmas time you can talk about math with this door. We have another door we created for teachers that they can do right inside their classrooms, where students can come up with their word, their synonym, their meaning of what perimeter means. You can take sentence strips, you can take instruction paper, and make that door for them so when they go in and out, they're seeing that perimeter, and they're seeing that area. So we have our teacher logic, we have the materials that are needed, then we have a must do, so they would locate, you would do this as a teacher. You would look at it and have it and anything has to be broken off square. And so, it'll take them.
Okay, what am I going to do here? Since I've got to
Just look at all the sides.
Just go ahead and update.
And understanding that those shapes that are irregular like that are called cubes. In second grade and 3rd grade, they are doing irregular shapes. They call them irregular. What you do is you use this right here.
They do each side and then they realize they're adding up all the sides.
So you use this grid paper.
Even if you felt like you could with them, have them take a long one, like you said, a long piece, like this yarn. And then they could work in pairs. Think about that. Think about your elves. They can be helping each other with that. That's the difference from perimeter. If they're talking about rim, they're talking about edge, outside border, yarn, and they can basically measure the entire thing with yarn all the way across. And then they can line up across the room and say, this is perimeter.
This one. We even talked about here, taking it and color coding each section so that they don't double count, and then going around and putting a tick and counting them. And then we talked about what do I do if they don't count this one? So we have sometimes they don't count these two. So taking, let's call these popsicle sticks, but they're not. Taking this and creating a irregular shape, right? And saying if we don't measure this one, then it's not really there, right? So if we don't measure this one, then it doesn't become, it's no longer a polygon. We cannot measure all the way around it. So it's pretty cool. It does the different levels, and then the whole time it's doing this. It's going to move into more shapes that are more difficult to do. The rigor goes up with every single level, and the entire time it's blinking that perimeter so that they know I'm doing the rim. See, now we go into irregular or compound shapes, composite shapes.